What if I told you that everything you think you know about distance is already wrong the moment you look up at the night sky? You see a star, and your mind quietly labels it far away, simple, clean, final. But that word far is doing something dangerous here. It is pretending that space is simple, stable, and fully understood. The truth is far more unsettling and far more beautiful. Because when you look into space, you are not just looking across distance, you are looking across time. The light entering your eyes may have started its journey before human civilization even existed, and yet your brain still insists on calling it now. So let me ask you something strange. If what you are seeing is from the past, and if space itself is stretching while you watch it, and if different observers can disagree on how far something is, then what exactly is distance? Is it a number, a measurement, or just a convenient story we tell ourselves to make the universe feel less chaotic? The deeper you go, the more unsettling it becomes, because space refuses to behave the way our instincts expect. It bends, it expands, it delays reality itself before it reaches you. And somewhere inside all of that, the idea of distance starts to lose its solid ground. But here is the real twist. This is not just about physics, it is about perception. It is about how your mind builds a version of reality that feels stable, even when the universe itself is anything but stable. And if that sounds confusing, good, because that confusion is exactly where real understanding begins. So before we continue, forget for a moment what you think distance means, because what comes next will challenge not just your knowledge of space, but your trust in the way you experience reality itself. When people hear the word distance, they think it is something solid and obvious, like a ruler stretched between 2 points. You imagine space as a kind of empty room where everything has a fixed position, and the gap between two things is simply how much emptiness sits between them. But the moment you start looking deeper into how the universe actually works, that simple picture starts to fall apart. Distance is not something the universe gives you directly. It is something you construct using assumptions, measurements, light signals, and even your own motion. In a very real sense, distance is not an absolute feature of reality, but a relationship that depends on how, when, and from where you observe. The first thing to understand is that space does not come with a built-in measuring tape. If you remove all objects from the universe, there is no obvious way to say what distance even means. Distance requires at least 2 reference points. Without something to compare, space becomes like an empty idea rather than a measurable object. Even here on Earth, when you say 2 cities are 100 kilometers apart, that number depends on the path chosen, the surface you measure on, and the definition of the unit itself. Now extend that idea to the universe, where there is no fixed grid in the background. Suddenly, distance becomes less like a physical object and more like a calculation we agree on based on conventions. When we look at the sky, another layer of complexity appears. The light we receive from distant stars and galaxies does not arrive instantly. It travels. That means every image you see in the night sky is not a picture of now, but a picture of the past. If a star is 100 light years away, the light entering your eyes today left that star 100 years ago. So in a very direct sense, the distance is not just spatial, it is temporal. You are always looking back in time when you look deeper into space. This creates a strange blending of distance and history. The farther you look, the older the universe appears, not because the universe is different, but because information takes time to reach you. So what you call distance is already mixed with delay, and what you call far away is also far back in time. Now things become even more unusual when you realize that the universe is not static. Space itself is expanding. This is not like galaxies moving through a fixed, empty room. Instead, the room itself is stretching. Imagine drawing 2 dots on a rubber sheet and then stretching the sheet. The dots are not necessarily moving across the surface, but the surface between them is growing. That means the distance between them increases even if they are not actively traveling. In cosmic terms, galaxies can appear to recede from each other simply because the fabric of space is expanding. This means distance is not stable over time. It is dynamic, changing, and tied to the evolution of the universe itself. A distance measured today is not the same distance that existed billions of years ago, even between the same 2 objects. This already challenges the everyday intuition that distance is fixed. But there is another deeper issue. Human perception itself is not built for cosmic scales. The brain evolved in a narrow environment where distances are small, speeds are slow, and signals are immediate. On Earth, you can throw a stone and see where it lands in seconds. You can walk across a field and directly feel the change in position. Because of this, the mind builds an instinctive belief that distance is straightforward and absolute. But when you take that same mental model and apply it to galaxies, clusters, and the observable universe, it starts producing illusions. 1 billion light-years sounds like a meaningful number, but your intuition cannot actually visualize it. So the mind compresses it into something it can handle, often underestimating the true scale or treating it as just a larger version of familiar distances. This mismatch between intuition and reality creates one of the biggest illusions in understanding space. You might think of space as a giant, empty stage where everything is placed at different fixed coordinates, but in reality, that stage is not rigid. It bends, stretches, and changes depending on energy, gravity, and motion. That is where the concept of spacetime becomes important. Space and time are not separate backgrounds. They are interwoven into a single structure. This means distance is not purely spatial. It is influenced by time, motion, and gravity. When gravity is strong, space itself curves. When speed increases, measurements of distance can change depending on the observer. So even something as simple as, how far is it, becomes dependent on the physical state of the observer and the environment. This leads to the idea that different observers can disagree on distance and still both be correct. If two observers are moving relative to each other, they may measure different lengths for the same object or different separations between the same 2 points. This is not a measurement error, it is a feature of how reality behaves. In high-speed conditions or strong gravitational fields, the rules of measurement themselves shift. So distance is not just something you measure once and accept forever. It depends on the frame of reference, meaning your motion, your position, and even your gravitational environment all influence the outcome. To make this more intuitive, imagine trying to measure the length of a river while standing on a moving boat. If you are drifting downstream, your measurement process is affected by your motion. Now imagine the river itself is also changing shape as you measure it. That is closer to how space behaves on a cosmic scale. There is no absolute still point from which everything can be measured universally. Every observation carries the conditions of the observer within it. This is why two correct measurements can still differ, not because one is wrong, but because correct depends on context. Now combine all these ideas: no absolute measuring grid, time delay in observation, expanding space, limited human intuition, flexible spacetime, and observer-dependent measurement. What you get is a picture where distance is no longer a simple number. It becomes a layered concept built from interactions between light, motion, geometry, and perception. In some sense, distance is more like an evolving relationship than a fixed quantity. It tells you how things are connected rather than how far they are in an absolute sense. Even the act of saying, "this galaxy is far away," hides assumptions. It assumes a model of the universe, a definition of distance, and a way of interpreting light signals. If you change the model, the meaning of distance changes with it. In some cosmological descriptions, two objects can even be said to be outside each other's practical reach, because space between them expands faster than light can cross it. In that case, distance becomes not just large, but fundamentally unreachable, not because of speed limitations, but because the structure of space itself is evolving in a way that separates them indefinitely. So when you think about space in this way, the idea of distance becomes less like a rigid ruler and more like a flexible interpretation of relationships in a changing system. It is not wrong to use distance in everyday language, but it is important to recognize what is hidden underneath that simplicity. Every number representing distance in the cosmos is built on layers of physics, assumptions, and definitions that are far more complex than the number suggests. And as you go deeper into understanding the universe, you start realizing that what seemed like a simple "how far" question is actually tied to the nature of reality itself, where observation, motion, time, and geometry all blend into one continuous structure without clear separation. So after everything we've explored, one thing becomes clear. Distance was never as simple as it first appeared. What we call far is not just a number on a cosmic scale. It is a mixture of light that took millions or even billions of years to reach us, space that is constantly stretching while we measure it, and a mind that is trying to compress an unimaginable universe into something familiar. The more carefully we look, the more we realize that distance is not a fixed property sitting out there in the universe waiting to be measured. It is something that emerges from observation, from motion, from time, and from the way the universe itself is unfolding. And this is where the real shift happens. Because once you understand that distance is not absolute, you also begin to see that reality is not as rigid as it feels. The universe is not a static stage where everything is placed at fixed positions. It is an active, changing structure where even the space between things has its own story. What we experience as simple separation is actually a dynamic relationship shaped by light, time, and the expansion of space itself. In a way, the illusion is not in the universe. The illusion is in how easily our mind turns something deeply complex into something simple enough to feel comfortable with. And there is nothing wrong with that. It is how we survive and navigate the world. But when we step beyond everyday experience and into the scale of galaxies and time itself, that simplicity begins to break apart, revealing a deeper and far more connected reality. So perhaps the real insight is not that distance is meaningless, but that it is far more flexible and interwoven with reality than we ever assumed. The universe does not just place objects apart. It defines what apart even means through the laws of space, time, and observation. And once you see that clearly, you can never look at the night sky the same way again. Good luck on your journey of curiosity and discovery. May you always question what seems obvious and find wonder in what initially seems impossible to understand. Thank you for your time, your attention, and your curiosity.